All right, so what we'll be doing is make sure I get the right screen share going. I want this one. Okay, so quick review. We put our stuff in assembly directory, and then I changed mine to HW1X. This is where everything works, at least in mine. Okay, and let's go back to here. So can you see that in the back? Kind of, sort of. Okay. All right. What I've done is that I've taken the code that I've given you and I've compiled it and I've got it working. Now, how many got the scanf to work to take the integer in? Okay. That's part of this problem. You need to get that to work. Okay. So what I did is this, is I simply, I guess I could use VI. A little hard to see, but I added those lines to allow my integer to be entered by the user. Okay. And I put it in main.c. Okay. Now, if you haven't done this yet, you'll need to get this working because this is how we're going to do our debugging. Okay. Remember, we'll become GDB experts and linkers, and you'll really know what a linker is and how to use the debugger by the end of this class, because that's where we're going to spend more of our time. Been talking to folks in industry and they're saying, yeah, the assembler stuff is nice to understand how the hardware all fits together, but you really need to know it so you can troubleshoot better. And what do you use to troubleshoot? The debugger. Okay. So I'm just putting in, enter an integer. Here's my scanf that puts the user input into my variable, and then it just prints it out, and then it adds it from our foo.c and foo.h. Okay. So if you look at your original code, it all worked, and then I gave you the demo that showed the scanf and printing it. Okay. So basically I took 2 lines out of the scanf, out of the demo 1, and put it into main, and I got it working. So let's make this work before we go any further. Okay. Now remember our compile line that we had to come up with? We needed GCC, and then we take our main.c and foo.c, give it output, and I'm going to call it enter 1, just for, then I want the symbols for the debugger, and then I want optimizations to 0. Okay. So I want all the optimizations, but don't optimize anything because I want to be able to bring it into the debugger. So that's the compile line I will need. That's hard to see, but that's an uppercase O is an Oscar, and then a 0. The fonts don't show that very well. Okay. So basically it's these 2 lines. Okay. And then once you get it changed, you compile it. In here somewhere. There it is. Compiles it. I'm going to run it. All right. Thank you, sir. And I'll say 8. And it adds 8 because that was one of our changes. Okay. So now your homework's done. Isn't it nice when your instructor does your homework? Okay. The idea behind it is I want you to learn the results of what we're going to do now. And I want to see you're growing into this, because I realize this is completely foreign. to almost all of you as far as what am I doing here? Okay. So let's bring up our list of labs here in 273 and then go down here to GDB, pick one of those. How about this minimal survival one? Okay. This is what I'm asking you to do, is kind of go in here and follow along. Now it's different code. Okay. There are some differences, but right here, here's some useful commands to play with it. That's what I want you to do today. We're going to play in the debugger, work together. Okay. It's helpful when you learn something new to learn it with somebody, because then you can bounce things off. And here's the beauty of that. You learn faster. In my early days, I had nobody to talk to about this stuff, and I had to go learn it on my own. You spend a lot of time trying to fill up those very, very basic little things. Like it took me a week to figure out how to make a shell script executable in Linux when I was first getting started in the world of Unix. Simple, but I didn't know how to ask the question because I didn't even know who to talk to. So once I figured it out, it's like forehead slap moment. Okay. So let's bring up our code in the debugger, and this is what we're going to do the rest of the day. Just play with the debugger. Okay. So what do we do now? We're ready to run this thing in the debugger. What's our very first step? We have to run the command gdb against what? Our executable, enter 1, as I called it. Okay. There. Oh, Q. If you use the Q for quiet or Q for quit, if I put in -Q, it quiets down the copyright. Okay. So you can actually just create an alias gdb and then create an alias that goes gdb-q anytime you're on gdb, and it does this. Now, this is where we go. This is what we're going to be tinkering with. Okay. Now you're saying, now what do I do? Well, those commands that I brought up over here are B, disable, enable, N, step or go, S, list, P, Q, clear, continue. Start with those. See what happens. Okay. So if I say L, notice what happens. It only gives me a list of how many. What if I want to go on? I say L 11. So this is where you make little notes somewhere and scribble it down, or create a notepad file or something to kind of help you remember some of these things. Okay. So that's L. Okay. Now, let's do, I can type in, what was it? He called it clear to clear breakpoints. So you can't clear the screen and continue normal execution. Let's see what happens here. Program is not being run. What if I hit R? Oh, there it is. R will run it. Now I'll put in my integer. add 8 to it. There it goes. Now, what is it telling you? It says, I'm running this program in memory. Now, here's what the GDB is doing. It's taking this chunk of RAM, putting it in and using it, but then GDB is creating another, shall we say, address space that goes around your executable. And what this thing is doing is it allows you to inspect that RAM from different angles, if you want to call it that, from using the GDB. Okay. So R ran it. Okay. L lists it. So I can say, let's just run it to the top, rerun it from the beginning. So let's do N to start with. Now notice what it says here, execute next line of code, but don't dive into the functions. We have functions that are called. So when we type in next, it will run our code. It'll call the function, do its thing, and continue on. If you want it to recurse the functions, we need another way to do that. Okay. This is only, there's like 800 of these things. There's a ton of commands that we can use in the debugger. Okay. And you're going to discover a lot more than just these. Okay. So for the next few minutes, play with these and see what you can find out. If I list it, can I run it? Or do I have to exit and go back in and run it from the top back down? What happens? What's a breakpoint? How do I set a breakpoint? What does that actually do? So this is hands-on experimentation to start building a framework as you can learn more about the GDB. Because if I gave you a quiz and say, here's the GDB, here's the lab, here's the monkey-fisted lab, you follow along, and I'll give you a quiz at the end of that monkey-fisted lab, you're not going to remember it. Okay? You learn by beating your head against the wall saying, why doesn't this work? Then it sticks. Okay? So play with these. Go for it. Have some fun. Work with each other. Also, use Google. Find out other things. I put some other links in there that are helpful. You can, now some people learn in very different ways. And I myself am one of the folks that learns by getting their fingers bloody. Okay. I get in there and I just work on things. Takes me longer sometimes, but I really learn it deeply on what I'm learning. Other people, I've worked with people like this, prefer to read everything about it before they even start. That's good, especially when you're doing something like learning something completely new. It's helpful to see how it fits together. Okay. So there's different ways to play with this. There's a start. There's this hello world is actually, we're going to be getting into that next week. What the assembler does. Okay. And here's a miniature class. It's one lecture out of another school for a engineering degree, I believe. It came from a hardware engineering side of the fence. Okay. And then here's one student's path. They basically said, here's how I learned GDB. I use this as a comment. And notice there's some things that we didn't talk about. This reassemble, disassemble, breakpoints, what's going on. We'll do that next. We'll do that next week, I should say, or Wednesday. Okay. So right now, play with this one and get started by making some comments on what you understand. You can do screenshots. I don't care how you document it. If you want to use the Linux box in front of you, the screenshots work. All you have to do, let's see if I can bring one up over here. Where is it? Oh, it's this one. All right. Let me bring up my machine here. You have, there's something on the Linux boxes that's called LibreOffice. Okay. Whoops. And if you just type in Libre, there's the Office writer, and you can click on that, and it brings up something that looks like Word 2003. Okay. And you can put notes in here. You can do your screenshots. You can paste it. It works just like Word. Okay. And once you save it, be sure to email it to yourself, because these machines, you know, the Jeremy box, it might save it, but it might not. Okay. So let me go here and hit print screen and go back over here, right click, paste. Oops. Yeah, I have too many virtualizations. I'm virtualizing a virtual machine, so the screenshots aren't working quite right. They'll work for you. Okay. Breaking too many rules. So let's play. Wednesday, we'll do this again at a deeper level, setting breakpoints and inspecting memory. Okay. And use your phone to take notes. I don't care. That works too. We're just playing with the debugger on the code we finished last week. Think of what we're doing this week with the GDB is the equivalent of learning how to use a mouse when you first got onto computers. Okay. Yes, we'll get that on next week. We're going to use the disassembler and actually look at it in assembler. Oh, good. Yeah, that's where we are. We got it, and then I showed what I did to get the code working. Let me go back to find it here. That's what I added, just so you can. Right. Oh yeah, yeah. That's where we're going. We'll get there. And I've talked to the other instructors, and we're kind of all on the same page that sticking with just the gas is low enough level for most of what we need at the junior college. When you get into physical hardware, you're going to need a different type of assembler that puts it into the actual hardware chip. We're not going to go that low. This will work, because the output of your GCC, Fortran, COBOL, C++, all the things that GNU compiles goes to gas. Yeah, and then you can do your target cross compilation, so you can actually make it run on a Raspberry Pi if you want to, which is kind of cool. We will cover maybe some of that, maybe not. Depends on how many machines I can find. Okay. So That's where we're going. We'll learn how to read that. Does everybody know what a breakpoint means? No? Yes? Yes. A breakpoint allows you to take your code and instead of running it all one fell swoop, you stop it on that line. That's what a breakpoint does. Pardon? It does. It does. It does. There's a lot of magic. The GDB program itself is massively huge. It does a lot of very deep magic. Right. Right. When you're working at say a PPI chip, a programmable peripheral interface, and you actually need to debug it, you have a different level of debugging capability because you're actually manipulating the registers on the chip. So you're, shall we say, you're much closer to the hardware. So when you're looking at address places, you are, you know, right where you are on that chip. This, when we look at address places, they're accurate to a point, but they're more relative than they are absolute because everybody gets a shared memory segment. So yes, you can look at what's in memory. Yeah, we will touch on that because that can break some brains when we start talking about you know, the old I-86 and we got your address space and you want to get past that 2 gig limit using the PAE. A lot of, yeah, it's like, yeah, it's you learn it, you forget it, and you learn it again. Okay. And it would be fun for you. There is a Rust compiler and Go for that matter that are part of the GNU suite. They are separate from Cargo and the Go compiler. The Go compiler that is the default doesn't use gas, but you can actually take Go and compile it with the GNU tool chain and get your gas output. So you can be using these same debugging tools on Rust and Go, but you have to compile them with the GNU suite, or you won't be able to. Yeah, yeah, yeah. And I said, well, that's interesting. This is the, I don't know where they get the money, but the people that write the GCC tool chain are gods. They get it from you. Yeah, like, wow. So this is where your homework comes in. You're doing your homework during class. You're explaining to me what you understand when you run the debugger. What is this doing? How does this break? And I encourage you to go watch some videos. Use the tools that are at your disposal, because what I will be bringing to you is some things to tinker with, and it's not going to stick for everybody. So you're going to have to go find what works for you to learn this stuff. Okay. Everybody comes from a different background. Everybody has a different level on this stuff. The idea is have fun. Because your homework assignment will be coming, as I will write out saying, write a main, write something and a header like foo.age, and make it do this and make it do that. So I'll be writing it out in English, and you'll be taking basically this code and duplicating it according to those instructions. And we'll be going through the gdbugger again with that new code that you wrote. That'll be homework 2.